My name is Jeff. This is Jeff Brown Tech. This is Module 1 inside of our PowerShell Command Line to Scripting video course. If you want to view the full playlist or get a copy of this code, both of those links will be down in the video description. Here we are out in Visual Studio Code. Let's go ahead and open up Module 1 for variables and data types. Go into README and check out the preview here. Let's have a little bit of introduction. First, we're going to talk about how to use variables, the different data types and operators that come with them, and then have a couple of coding challenges for you to complete in order to get more familiar with these topics. Inside of this module, we are going to cover declaring and using variables, understanding PowerShell data types, using operators to perform calculations and comparisons, looking at some different methods for our different variable types, and then again, our hands-on challenges to reinforce the skills. This is broken down into 3 lessons. The first lesson is working with variables. The second lesson is exploring our different data types. And lesson 3 is using operators with our variables. We then have 2 challenges at the end of the module covering a sentence analyzer and then a temperature converter. Let's go ahead and close out this README and open up our first lesson here on variables and this Jupyter notebook here. And let's go ahead and get started. First, let's talk about variables. These are a core component of any programming language or anything you do inside of scripting. You've probably already been using variables with PowerShell. We're just going to cover some basics and just make sure we set the foundation level here and we're all on the same page. Variables serve as placeholders for your data. You can store, retrieve, and manipulate it dynamically inside of your scripts or out on the PowerShell command line. They can accept user input. You can use them for data processing. Again, just a fundamental concept here. You've probably already also seen variables. Variables inside of PowerShell are designated with a $sign. Anytime you see a $sign and a word, that means that is a PowerShell variable. There are a couple of things to understand about PowerShell variables. They are not case sensitive. So if you have a variable inside of your script or the command line and it's $name and it's all lowercase, that is the exact same variable as if $name all uppercase or mixed case. Those are all referring to the same variable and they'll all have the same value. Other programming languages are not as flexible. Something like Python or I think even C#, they are case sensitive. So if you have something like $lowercase name and uppercase name, those can refer to 2 separate variables and have different values. PowerShell is not as stringent. It doesn't care about the casing of your variables. So just be aware of that if you are doing that inside of a script and you're wondering why they have the same value or they're not different, that's what's happening. Variable names can include alphanumeric characters and special characters. However, I would limit special characters to maybe just an underscore, maybe a dash if that's accepted, but just try to avoid that as a best practice. Now, we just talked about variables and being case sensitive and how they're not, but you should keep a consistent capitalization strategy when you're writing your scripts and functions. And there's 2 formats to consider here, Pascal case and camel case. The first example is Pascal case, and I wrote the name Pascal here in the format that it is, where each word in the variable starts with an uppercase letter. So we have capital P for Pascal and C for case. There's no underscores or special characters. And this formatting matches built-in PowerShell variables that you'll come across, such as error action preference. Notice how everything is capitalized, the first letter in each one. And then here are a couple examples of what this would look like. Username, capital U, capital N, total files, server status. Our second option here is camel case. Notice how we have lowercase c in camel, but capital C in case. That follows the format here where the first letter is lowercase and then the rest are uppercase. Again, no underscores, special characters. And then our same examples here, username, total files, and server status. I asked the PowerShell community on Blue Sky a few months ago which format they typically follow. The general consensus was you'll use Pascal case if you are writing out your parameters, which we'll cover in some later modules. And then inside your scripts and functions, you use camel case and probably use camel case most of the time. If you're out on the command line and you're just typing stuff out and getting things to run, not a big deal what you use there. Inside your scripts, I would follow this same formatting where this is parameters and these are other variables just to distinguish between the two. The main thing is just be consistent. Again, since PowerShell variables don't care about case sensitivity or anything like that, just be consistent in what you're doing. Next, we just look at what it takes to declare some variables. We have $sign in the name of our variable. We have the equal sign. This is an assignment operator, and we're setting this to hello world. Since it has quotes here, we know it is a string. We can assign numbers here, integers. That means they don't have decimal places. Here's pi and 3.14. So this is a floating point number. And then we also have other built-in variables. And I'll notice we have is ready, but then we have equal to another variable. You can't take a variable and assign it to another value. And this $sign true here is a Boolean value, means true or false, on or off. And these are built-in variables. We'll talk about those later, so you don't have to declare this ahead of time. Now let's jump out to just a very small exercise here in declaring variables. We saw this in the introduction video. Right now, if we take a look at our code, we are writing out hello $sign name here, but we actually don't have that variable declared anywhere just yet. So our first goal here is to define this variable right here and give it a value. We'll do $sign name. Since this is a string, I'm going to put quotes around it. And let's go ahead and run this. Again, we might have to run this multiple times to get it to run the way we want it to. And third time's a charm. We now see hello Jeff. $sign name is holding the value Jeff, and it will display it out onto the screen for us. Now, we talked about the difference between PowerShell and other scripting and programming languages and case sensitivity. There is another concept here I want to cover, in that PowerShell is not strongly typed. Again, one of the differences between PowerShell and other programming languages like C# or Java, PowerShell is not strongly typed. This means PowerShell will automatically determine the type of variable based on the assigned value, and it allows you to change your data type dynamically. Things like Python do not allow this, C# does not allow this. But what does that mean? What does it actually look like? We have implicit and explicit typing of our variables. By default, PowerShell does not enforce specific data types when assigning values to a variable. This is implicit. So what happens here if we say our value variable here equals 10, PowerShell goes, oh, that's an integer. That means value is now an integer data type. However, PowerShell does not stop us from changing our data type just as we assign it another value. We have our value variable here, and we assign it a string value, and it goes, okay, now value is a string. I don't care. I'll let you make this change. If you're declaring variables, you can be very specific on what type of data type they should be. So here we have count, and inside of our square brackets here, we're saying this is an integer or an int equals 42. We have username. We are saying that is a string. We're giving it admin as a string. And then is enabled, we're saying is a bool or Boolean value, and it is equal to true. If you're declaring variables implicitly like this, you can change the different data types between them. If you're being more specific here and saying, this is an integer, this is a string, then PowerShell does not allow you to change the data type. So that way you're being more specific about it. Let's just run this example here. We first have our count variable. We're saying it is an integer equals 42, the number. And then we're going to try to assign 42 written out as a string. And let's see if PowerShell allows us to do that. As you can see, it comes back and it says, sorry, you cannot convert 42 to system or an integer 32. It's just saying count is an integer and you cannot assign 42 to it like this because this is a string and they're different data types. Now, the important thing is, why does this matter? PowerShell can allow you to change your types dynamically, but if you're doing that and you're working with other variable data, you can run into unexpected behavior. For example, let's say we are creating a variable here called sum, and we have 5 as a string, so it's in quotes here, plus the number 10, so an integer. What do we think is going to happen here? Is it going to come out as 15? Is it, what's going to be our answer here when it actually puts these together? So let's go ahead and run this cell. You can see it comes out with 510. In this example, PowerShell sees this as a string and it says, oh, you're trying to add these together. You're trying to maybe concatenate them. I'm going to convert 10 here, the integer, into a string, and then just create a new string here. So if we were to look at the data type of sum, it would actually be a string, and it's a string made up of 3 characters or numbers here, 5, 1, 0. So that's what I'm saying is you can start mixing up your data types here, but it can lead to unexpected behavior. As I just mentioned, if you want to know what your data type is for a particular variable, you can use a method here called getType. So you just look at your variable, you add a little period there, and then here's a little method called getType, and it will return what type of variable it is. So if we go ahead and run this, we can see the first option here that we use count getType. It's an integer, username is a string, and then our isEnabled is a Boolean value. You'll see this in other programming languages where if you try to put a number in a string like Python, you actually have to convert the number into a string and explicitly do that. PowerShell is a little more forgiving. It'll do that for you automatically. As I mentioned earlier, there are some different variable types. Let's just go through a couple of examples of those. We've already been talking about user-created variables. You create them in the command line or in your script. You're assigning values to them. You're changing them. You can delete them. There are different scopes to values. We'll talk about that in another section coming up. We have automatic variables. These are created and maintained by PowerShell, so you don't have to create them. One of them we already saw was the $true. That's a Boolean value. PowerShell creates it. You don't have to do anything with it. Some other examples include PS home, which just shows the home directory for PowerShell. We have $, $underscore, which represents the current object in PowerShell pipelines. We'll talk about that concept later on. We have our profile where you can store things that load up automatically when you start PowerShell. You can look at your current edition of PowerShell in this automatic variable. If you want to read more, I do include a link here out to Microsoft documentation to read more about automatic variables and some other examples. We do have preference variable types. These are ones that store user preferences in your current session. These do come with default values, and you can change the value if you want to inside your session. Some of these include maximum history count, and then we also saw error action preference earlier when talking about casing for PowerShell variables. Finally, we have environment variables. These store information about your current system, whether it be the operating system, current user logged in, maybe what domain you're on. These are all prefixed with $env and a colon. Some ones you might be familiar with already is your PS module path, so where your module is installed, and taking a look at your current operating system. You can also create your own environment variables. So you probably can't change the value of most of these environment variables here, but you can create your own. You just need to do $env and a colon, and then your variable name, and set it to your new value. Again, environment variables on macOS and Linux are case sensitive. In Windows, they are not. And you typically find that Windows is less caring about case sensitivity. Other operating systems like macOS and Linux care about case sensitive things. So for example, these two variables on those systems would be different environment variables. If you want to read more about other environment variables, I included a link here to Microsoft documentation. Go and take a look at that. Next, let's talk a little bit about variable scope. Scope determines where a variable is accessible within your PowerShell session, script, or function. This doesn't come up too often, but I've ran into sometimes issues with PowerShell scope and how it affects and behaviors inside of functions and everything. So a good thing to be aware of, but typically you probably won't come across too many issues with it. Our first type of variable scope is our global scope. This means it is accessible anywhere within the current PowerShell session. If you want to define a variable and explicitly state it as being in the global scope, you just prepend your variable with global and colon here, and then your username, and then set it to whatever value you need to. We also have script scope. Now the script scope variable is only accessible within the script where you are declaring it. And if you want to be very explicit and make it a script scope, you prepend it with script. Next, we have local scope. This means variables declared inside of a function only exist inside that function unless you explicitly define it as otherwise. Let's take a look at this example here where we're writing out a function. This function called test scope, and the important thing here are the curly brackets. Everything inside of these curly brackets is related to the body of our function here. We have a local variable only inside this function, and we write the output. So what we do first here is we run test scope, which runs our function and outputs our local variable value, and then we also try to output it outside of that in our local session. And what it's going to say is this variable is not found. In fact, let's jump out to a PowerShell window here. I've already defined my test scope function. If we were to run test scope, we can see that it will output only inside this function. But if I try to bring up my local var outside of that function, you can see it doesn't return an error, but it just comes back and it doesn't display a value because outside of that function, this variable technically doesn't exist and doesn't have a value. If I wanted to, let's bring back up where I defined this variable. And if I wanted to come in here and say global and then redefine my function here, if we run test scope, we will see that. But then if I do local var now, hopefully, yep, it'll come out and give me the value of that. So when I define this variable here inside my function with the global scope, it makes it available outside of this function and I can access it. I do have another video talking about script scope and everything like that. I'll include that in this playlist as we're going through these videos. One of our last scopes here is called private scope, which means the variable cannot be accessed outside its defining scope, even if another scope would normally inherit it. And as I pointed out here, private technically isn't a scope. It's just an options that change the accessibility of it outside the scope it's defined. If you don't define a scope within your variable, it's assigned to the current scope by default. If you create a variable inside of your script, then it's script scope. If you do it inside of your PowerShell window, your command line, it's probably got global scope. If you put inside your function, it's just going to have the local function scope. Typically, when you're defining variables, you don't need to define a scope with them unless you want to change its behavior. As I said, you'll rarely need to define variable scopes, but just be aware those different scopes do exist. All right, that does it for our first lesson on variables. Let's go ahead and close this notebook out and let's go into our next lesson on data types. In this section, we're going to cover common data types you might find inside of PowerShell and include or introduce the concept of methods. First data type here is strings. We've already been seeing strings as we talked about defining different variables. These store text values. You can define them with either single or double quotes. Single quotes means it gives you the literal variable. There's no variable expansion. Double quotes gives you variable expansion, meaning PowerShell will display the variable's value. I should say variable, not strings value, or either or, I guess, in this case. What does this mean exactly? Let's just jump down to take a look at our example here. I have a variable called name, and it has a value of Bob. Now, if I do write output here inside of single quotes, you can even notice here Visual Studio Code is displaying the name variables differently here inside of single quotes and then here inside of double quotes. Let's just see what this looks like in action. And you can see on our first line here inside of single quotes, that means it gives us the literal string. It doesn't care that there's a $sign there. It doesn't know or care that it's a PowerShell variable. So it comes out and says literally $name and hello name. But if we put inside of double quotes, it will expand out and give you whatever that string value is and actually put in the value here. So that's the difference whenever you're looking at single and double quotes. Now, sometimes when you're outputting something like this and you want to perform an action or a calculation on your variable and you want it to also display into a string, you have to do something called sub-expression expansion. And that's where you put your variable like $name inside of $sign and open and close parentheses. And you typically use this when you have it inside of double quotes. We'll see some more examples of this later on. I just wanted to introduce this concept here. So when we see it, we know exactly what's happening. You just use it to enclose calculations that you're performing inside of a string. Our next data type is numbers, and PowerShell supports different types of numbers, including whole numbers and decimals. We have integers, and integers take up this range here of negative, whatever this is, to positive. We do have 64-bit whole numbers that are in a much larger range, so if you're dealing with very large numbers. We have floating point numbers, double numbers, decimal numbers. These are all, with a period in them or have decimals inside of them. Whenever you're declaring variables with whole or fractional numbers, PowerShell will default the whole numbers to integer and the decimals to double. So most times, unless you're writing some application dealing with finances or very scientific things, you probably don't ever really need to declare or make sure you use floats or decimals, but just be aware there are different types of decimal or floating point type numbers there with fractions in them, I guess. Now we introduced the sub-expression expansion here because I wanted to include this example here of it. So notice we are defining a couple of variables here, number 1 and number 2. We're going to take a look at their data types because one's a whole number, one has fractional components to it. We have, if we want to output our type of data type inside of our string here, we have it enclosed in double quotes. Then we have a $number, which is our variable type, .get type. We already saw an example of this inside of lesson 1, talking about different variable types. So we're running that. But we want that to evaluate and then display inside of our string. So that is enclosed in $open parentheses and close parentheses. And we're just going to take a look at each of their data types here. We'll run this, and it says 389 data type is int, 134.2938 is of double type. Our next data type, we've already seen examples of it, are Boolean values. These are true or false, and they are very good at just testing conditions inside of your scripts. Is this true? We'll do this. If it's false, we'll do this. They're represented by $true, $false. Those are automatic variables. Don't have to define them or anything. They're just there for you automatically. Next data type is hash tables. Now, hash tables are defined using an @ in our curly brackets, and they represent key value pairs. In this example, this might be a student record here. So we have $student equals at an open curly bracket. And we have our key of name and our value of Alice as we go through different components there. And then it ends on an ending curly bracket. Now do notice this is multiple lines. You don't have to do anything special going from line to line here. PowerShell recognizes that it's inside of some curly brackets here. And as you press enter, it'll keep all this together and evaluate it as one statement. So let's go through and define a hash table here, just like we did in our example there. So we have student is our type, or is our variable name. So we'll just run through and say Jeff. He is a senior. His major is finance, and he lives in Clark Hall. And then we'll just output this to the screen there. And you can see this gives some automatic column names here. Here's our name, and then here's the value of each of our keys. Now, hash tables are fine. Like we just did an example of here where this is maybe representing a single record. If you have some data that is only comprised of 2 components, a name and a value, you can include multiple in here. Let's say we had a list of server names associated with their asset information or something. As your key or as the name, you can have the different server names, and then as their values, their asset number, and you could just have a giant hash table. And what you can do is also iterate through a hash table if you needed to. But just for example, that's what you could also do with it. Now we have our whole record here, but you can access individual components inside of your hash table using square brackets here. We have our student record here. And if I want to just get the name value of our key here, you do our square brackets, and then in single or double quotes, you can put in the name of your key, and it'll just output the value here. So let's run this cell and take a look at it. We can see it outputs Alice and then computer science. Our next data type is arrays. Arrays are lists of information, and you can use them to store multiple values. The values inside of an array can be a string, a number, hash table, or any other data type or object. These are useful when you want to work on a large data set of multiple things. It could be a list of users, a list of servers, maybe files you want to manipulate or perform operations against. We define variables using the @ sign and then open and close parentheses. When you're defining arrays, you can create an empty array to start out if you don't know what's going to be inside of it. So you can just say the name of your variable equals @ and open and close parentheses. Or if you want to, you can define values in it automatically. It's just inside our parentheses here. So we have apple, banana, cherry, figs. We have an array of strings here. Let's go through and let's define our first array here. So we have favorite foods. We can say something like ice cream, cookies, really good stuff here, and then apples or something like that. And then when we execute this cell and output it to the screen, notice it puts it in a list there, so each item is on its own line. Now, again, PowerShell is very flexible. You do not have to have all the same data types inside of your array. I have an array here of random things. I have a string in here. I have a number. I have a Boolean value, all different things. Other languages are not as forgiving, but just understand PowerShell is pretty flexible and we can put any different types of data that we want in here. Now we saw in our example up here where we outputted favorite foods to the console and it put every item inside of our array out to the screen, but we can't access individual components inside of our array using indexes. The first item in your array has an index of 0, so arrays and their indexes always start at 0. And as you iterate or go through the rest of the items in the array, that index increases by 1 each time. You can then access, much like our hash tables, you can access those individual values using square brackets. Here is our fruit array written out in a table here in its index. So the first value inside of our fruit array is apple. It has an index of 0, and then 1 for banana, 2 for cherry, and 3 for figs. If you wanted to access cherry inside of our fruit array here, you would use an index of 2, just like this syntax right here. Let's see what it takes to access our indexes here in our example. So we have an array of sports names, and you want to just pick your favorite one there or look at other maybe. Let's go into sports here real quick, and let's just say gymnastics. So gymnastics, if I wanted that one, this would be 0, 1, 2, and then 3. So we'll put 3 inside of there and run our cell, and it outputs just gymnastics to the screen. Now here's a fun fact, and I use this quite a bit, is we were just looking and we have positive numbers for our array indexes, but you can actually use negative numbers to go backwards through the array. For example, we have our fruit array again. That would mean figs is -1, cherry is -2, and that just works backwards through our array. So let's go ahead and run this, and we see -1 should output figs, and we have figs, -2 should output cherry, and that's cherry. Most of the time, I just use -1 if I want to get the last item in the array. But other than that, I don't use negative indexes very often. Now, as we saw earlier, we can define arrays and they can be empty and we can add items to them later. So let's take a look at what that looks like. Now, arrays are a fixed size, meaning when you declare array, its size is whatever size it is, and typically you cannot change it. There are some exceptions in here. We can use the += operator. What that actually does is it takes whatever you want to add to the array and it builds a completely new array to store that value and that new array will be then of a fixed value. So for example, here we have our fruit array again, and we're going to output the contents to it. And then we are going to add eggplant to it. So we're going to say +=. No, we haven't learned about the += operator yet. That is coming up in another lesson. Just understand what we're doing is saying we're taking fruits and we're going to add eggplant to it and then add it back to the fruit array. In this case, we're actually making a whole new array. So if we execute this cell, we can see the current array items are 4 items there, and then our new array is 5 with eggplant at the end of it. If you want to remove an item from an array, it's a little bit trickier because we don't have the minus or subtraction option here. We do have an operator called not equal or NE. We'll learn more about operators in the next lesson. But what this does is it allows you to say, give me everything not equal to this, and it will remove that item from the array. In this example here, we're looking at our fruit array again, and then what we're saying is give me all of our fruits that are not equal to banana, and we'll save that back into a new array called fruits and then output that. So if we do this, we can see apple, banana, cherry, figs, but then our new array is apple, cherry, and figs because we removed banana because all of these do not equal banana. Now doing these options here, adding and removing items from an array, I do have a note here. This is fine on small arrays. There can be a performance issue if you're working with a very, very large array. As I mentioned, because as you go through and try to add or remove, technically what you're doing is creating a whole new array. If that array has a lot of items to it, creating that new array can take up some memory space there as you do that. If you're needing to add and remove items from an array, what you'll want to do is actually work with dynamic arrays. But otherwise, the methods I indicated above will work most of the time in most of your scenarios. If you want to learn about dynamic arrays, I do have a blog article about that, and I'll include that video in this playlist because I've done a video about this before. Next, let's talk about methods and properties on our variables and data types. We've already seen a few examples of these so far. A method is a function that is associated with an object, and you can use those methods to perform actions on the object. And what's great about PowerShell is built on the .NET framework, and that's where we get a lot of these built-in methods. You don't have to go define them yourself or anything like that. The key characteristics you'll notice about methods are they belong to specific data types. So strings have their own methods, numbers and arrays all have their own methods. Again, they perform actions on the object. And sometimes you can pass in information or parameters to customize their behavior. And we use the dot notation to access them. The next thing that looks very similar to a method is properties. Now, properties is an attribute of that object, and it holds information or more data about the object. The difference between properties and methods: properties store information while methods perform actions. Just like methods with properties, they belong to their specific data types. They hold more information about the object. We also access them using dot notation or a period, but they do not accept parameters, unlike our methods. If you want to view methods and properties associated with a variable, you can use the get member commandlet. So you can run get member and pass in your variable that you have defined there. Or what I typically do is take my variable and I pipe it over to get member, or GM is an alias for get member. And so you might see that in other documentation. Let's take a look at what our different methods and properties look like on a couple of different data types. First, we have strings here. I have a string called hello PowerShell. One of its properties is the length, so how many characters are inside of that string. But then we have some other methods here of to upper and to lower. It'll uppercase or convert it to lower and uppercase. We have another method. This one accepts parameters where we can replace text inside of the string. So I'm going to replace the word PowerShell with the word world. Our other options here is we have our string here. Notice it has some white space at the beginning and some other dashes at the end. What we can do is run .trim. It doesn't accept any parameters or anything. And what that will do is take care of any white space we have at the beginning or end of our string. We can also trim specific characters. So I can say trim end, and I pass in the dash here, and that's going to remove the dashes out of my string. One of our other methods that we have here is the split method. We have a string here of the quick brown fox jumps over the lazy dog. We have a sentence. What we can do is pass that variable and use .split, and we're passing in the string here, or a space here inside of quotes. There is a little space in between these two. What this will do is split the string based on each space and give us a new array. We are turning this sentence into individual words. So let's run this and take a look at all the different outputs for it. First, we have the length of our string of hello PowerShell at 16. We have it in lowercase, we have it in uppercase. And here we replaced the word PowerShell with the word world. One thing I want you to notice, and we'll see this in the next examples also, we have here we did 2 lower and 2 upper. But if you notice when we did the replacement here, it says hello world and it's not in uppercase. That's because as we're performing these actions here, it's not actually changing the original value of our variable. It's just displaying it out as we want to take the action on it. If we wanted to actually convert this to uppercase, we would do something like $greeting equals greeting.toUpper. And that's the action we want to take. So what that would do is convert all of it to uppercase and then assign that back to greeting or maybe a new variable. Again, these actions or methods that we're taking on it is not manipulating the original variable. It's just making those changes and displaying it to the screen. We see that here also. We have trim. Originally, we have some space here, but then we ran .trim. We can see that space at the beginning is gone now. But then if we do trim end to remove these dashes at the end, notice it outputs and our spaces are back here because we didn't actually change the original variable value with these actions here. It just made those changes and put them out to the screen. Finally, let's look at our split method. We took our sentence here and turned it into an array of words where each word is an item inside of our array. Next, let's talk about arrays. This is our other data type. We have a couple of different methods we can perform on it. We have an array of foods here. We can get the count and the length. This is just the number of elements inside of our array. And we have other data actions to compare to see if there's information in them. So does food contain taco? This is going to give us a Boolean value. It's going to output true, but does it contain ice cream? We look at our items here. No, it does not. That will output false. And then we can also clear or remove all the elements out of our array. Go ahead and run this. We see 4 and 4. That's the count and the length. And then we get true because it does contain taco, and false, it does not contain ice cream. If we were to run food again try to output it to the screen after we did clear, it should return. This one actually does remove and modify the original variable item there. Depending on the values in our array will depend on what methods we can use on it. We just saw we use contains on an array of strings, but that would not work on an array of integers or other number types. So if you had an array of numbers, you can't say, does this array contain this number? It just would not work because this contains is specific to string methods within the array. Next, let's take a look at hash tables. We have our student hash table here with our information on it. Again, we can run count to see the number of key value pairs in it. We can verify keys if they exist inside the hash table. So we have contains key name, that will be true, but contains key roommate, that is false because none of these keys here are named that. We can also verify the values that exist. So does our hash table contain a value? So that's the right side of our equals sign here. Does it contain Alice? It does, but it does not contain a value called Kathy. If you want to just view all the keys in a hash table, there's .keys or .values. We'll go ahead and run this. As we saw for true, false, that's our expected there in checking keys and values. Just the keys on the side of our hash table is our 4 entries there, and just the values output it there. Now we've been talking about our methods that are associated with our different data types. I do want to cover instance versus static methods. The ones we've been looking at before with, say, .method name, contains or whatever else, these are instant methods. However, like we mentioned earlier, PowerShell is written on .NET, so we have access to the .NET classes and namespaces and everything. You can access those other methods if they're not built on top of our data types, and these are called static methods. So for example, there's not many methods, instance methods associated with numbers. However, there are a lot more options inside of the .NET PowerShell language. If you wanted to, you could access those through the math class, and you put in square brackets here, the class name, and then the name of your method. For example, if you wanted to find out the square root of a number inside of PowerShell on the number object type, there's not a method called square root or something like that, but you can access it directly within .NET. So we have our number here, 25. We have our math class inside of square brackets, 2 colons, and then we can access this static method here of square root and pass in a parameter of our number, and it will perform that calculation for us. If we run this, the square root of 25 is 5. I only bring this up because if you come across somebody's script where you see just this notation right here or this syntax, just know that they are directly accessing these static methods inside the .NET framework, that this is not necessarily built into PowerShell, where we couldn't just say, number dot square root, and it would do that calculation for us. You can write your own instance methods and everything if you want to, but just letting you know, if you see this syntax, that's what it is, just working directly inside of .NET. Okay, that finishes up lesson 2. Let's go on to lesson 3, where we are going to talk about operators. Now, operators inside of PowerShell allow you to compare, manipulate, and combine data stored inside your variables. We can use these to perform calculations, evaluate conditions, and modify strings or arrays. We just saw an example of one of these in our array. If you want to remove an item from our array, we use the -ne, which means not equal to. And let's go ahead and dive into some of these comparison operators. Whenever you use one of these comparison operators, you use it to compare your values, and it returns a Boolean value, true or false. First, we have equals, indicated by -eq. So for example, we have $, or we have variable A, is it equal to B? True if it is, false if it is not. Same thing with not equal. If they're not equal to each other, then you evaluate to true. We have greater than, less than, greater than or equal to, and less than or equal to. This is just a small number of comparison operators. There are more. You can do some where case sensitivity comes into play if you want to make sure uppercase name equals uppercase name, or lowercase name, or mixed case. You can evaluate based on that. You can do case insensitive. I think it will just add an I to it. There are a few more. I just wanted to highlight the main ones here that you're probably going to be using most often. Just know there are definitely more. Let's go look at a quick example and run it here. We first have our age variable equal to 25. And we're going to output, is age greater than 18 or is age less than 18? And the first one should be true and the second one should be false. We'll go ahead and run this. And run it again. Get it a couple times here, and perfect. Get the results we're looking for, true and then false. Next, we have string-specific operators. You can use these when working with your string variables. Our first one here is -match. You can check to see if a string matches a specific pattern, and this does support regular expression or regex. In this case, does PowerShell match shell? Does shell, is that, combination of letters, that string, does it match something within this existing string? That is true. We have -like. This is a pretty common one. I use this quite a bit. You can see if the string matches a wildcard pattern. In this case, we have our PowerShell string. Is it like power? And notice we have the asterisk or the wildcard here. This means the beginning of the string is going to start with power and what comes after it. This could be PowerShell. This could be power car, whatever you want after that. But if there was something before PowerShell, like my PowerShell, this would not match because you did not have a wildcard at the beginning. Next, we have join. It will join multiple values into a single string. So we have 2 strings here. We have hello, and then comma separating these, and then world. And notice it is in parentheses. So we're evaluating these 2 strings together. We can say join, and there is a space here, but this is what you want to join the 2 strings, what you want to have occur in between them. So we have hello world with a space in here. If we were to put a dash, it would say hello -world _ hello _ world. whatever you want to do here, whatever you want to join those strings together, just put it inside of quotes. And we've seen an example of split already where you can take a string and then turn it into an array based on a delimiter or a specific character. Again, we have hello world. This is now a single string, but we're saying split on the space in between here. And then we have hello and then world on separate lines. This turns it into an array. Let's take a look at our code example of some of these operators in action. Again, we have our name is PowerShell. We're going to say is name like power. We know that's going to output to true with our wildcard there. We can join our strings, and then we've seen this example already before, taking this sentence here and splitting it based on the space and turn it into an array of words. So we have true, hello world, and our array. Next, let's talk about some number or arithmetic operators. Pretty straightforward with basic arithmetic. We have a plus sign for addition, so we can add two variables together. We saw an example of this a little bit earlier with our 5 string and our 10 number. It just turns it into a string, but if it was two actual numbers, 5 plus 10 would be 15. We have minus or subtraction, multiplication, and division. Now we actually have two different operators here that work with division that you might have learned in elementary school. First, we have the forward slash, which is regular division. This gives you the quotient. Let's say you had 10 divided by 5, that would equal 2. But then we also have the percent sign. This gives you the modulus or the remainder. So what's the remainder when you divide these things by each other? Again, if we had 10 modulus 2, that would actually be 0 because there's no remainder. 2 goes into 10 evenly. But if you had 10 modulus 3, that 3 goes into 10 only 3 times evenly, and then you have 1 as the remainder. So if you had 10 modulus 3, that would actually give you an answer of 1. Using this modulus is a really good way to test if a number is even or odd. You can say if 10 modulus 2, if that is equal to 0, then the number is even. If it's not equal to 0, that means the number is odd. Then let's just take a quick look at a couple examples. We have our sum here, 10 plus 5, that should give you 15. And then exact example that I just ran, 10 modulus 3 should give us 1. So our sum is 15, our remainder is 1. Next, we also have assignment operators. These allow you to modify variable values and assign the result to the same variable or a different variable. We saw an example of this already with adding to an array. We had our plus equal. What this is actually doing is, let's go to the equivalent to, let's say you have x plus 5, and you're taking the answer of this and reassigning it to the value of x. You can do a shorthand of that of just saying x plus equal 5. Again, what you're doing here is you're saying this variable plus this one, and we're going to assign that answer back to the first variable. Same thing with subtraction, x minus 3, and assign that back to x. You can shorthand it, x minus equal 3. Multiplication, division, modulus, all the same concepts here of just the shorthand. And then these last two are very important when we start working with for each loops and everything. We have plus plus and minus minus. What these do is just increment or decrement the variable value, which should be a number, by 1. So you can say x plus plus. This is equivalent to saying x plus 1, assign it back to the value x, and then minus minus. Essentially, just shorthand for adding 1 or subtracting 1 from the variable value. And let's go through and watch our assignments in action here. We're saying we have x equals 10, then x plus equal 5, that should be 15. And the same thing, we now have y equals 15, minus 3, assign it back to y, that should give you 12. Multiplication should give you 24 here. And that gives us exactly what we're looking for. Next, we have a couple of logical operators. These help you evaluate and compare your variables, and they return true or false. The first example here is dash and. what you do is you have two different conditions and you can put and in between them. And you only want to continue if the first condition is true and the second condition is also true. Both of those have to be true in order for the whole thing to be true. For example, here, let's say our variable a here is 10. So we'll try to write that out there a little bit. Is 10 greater than 5? Yes, it is. So that will be true. Let's say our variable b is 3. 3 is less than 10. That is also true. That means this whole thing will evaluate to true. If, let's back up here, and let's say b was 15. Well, 15 is not less than 10, so this is false. This is true and false. This then actually evaluates to false because we need both of these to be true in order for the whole thing to be true. Or is just a little bit different here. Our entire condition will be true if at least one of our comparison operators is true. Again, let's say 10, a is 10, so is 10 equal to 5? Let me just overwrite that there. Is 10 equal to 5? Nope, that is false. Or we'll say b is also 10. Is 10 equal to 10? That is true. So then this whole thing ends up evaluating to true because you only need one of these to be true for the whole thing to be true. It's one or the other. And then we have the not operator. And as you'll notice, I also have the exclamation point here. This reverses your condition. Whatever it evaluates to, it will give you the opposite. We'll say 10, or a is equal to 10. Is 10 equal to 5? No, it is not. So inside of here, this would be false. But since we have the not operator here in front, this whole thing ends up just evaluating and giving you the true response. I don't often use not. I always try to do a comparison that will result in true if I want it to continue. But it does come up occasionally, and you'll definitely see it in other people's code. Instead of seeing not here, you also might just see an exclamation point and just know that's saying the opposite of what it ends up evaluating to. Okay, let's take a look at our code example here real quick. We do have age is 25 and then is member is true. We'll place in our values here. We have 25. Is 25 greater than 18? It is. So this evaluates to true. And is member. Now notice we don't have an operator here. We're not saying greater than, less than, equal to, like, or anything. We already just have a Boolean value that is equal to true. That means this side is automatically true. We have an and operator. That means both of these have to be true for this to be true overall. And sure enough, it is. So we have true, true, and then this whole thing should be true. And then just a quick example of showing the opposite. So we know is member is true, but we want the opposite of that because we have the not operator here. So this will evaluate over to false. Next, we have our age. We're going to set it to 21 and has permissions is false. Our age value here, let's just place it in here. 21 is greater than or equal to 18. Perfect. That is true. Or has permission. Permission is false. But we have an or operator. One of these is true. That means this whole thing is true. We don't have to worry about. What's interesting here is since this is an or, you could look at this and go, oh, this is already true. I don't even care what's on the other side of this. I already know that this is going to evaluate to true. But if it helps you walk through the syntax or the logic of it, just walk through, double check everything, and this should output to true. We'll go ahead and run this. Clean it up here. True, false, and true. That is our expected output that we have here in the comments. Next, let's talk about operator precedence. So what happens if you have more than one operator occurring inside of your statement? This follows the rules that we learned in early math of the order of operations. First, we have parentheses. Anything inside of parentheses is going to be evaluated first. And then left to right inside of our statement, we're going to evaluate multiplication, division, and modulus operators. Next, from left to right, we'll take care of any addition, subtraction. And then we take a look at our bigger comparison operators like equal, greater than, less than, like, things like that. And then those comparisons are, if they are brought together through logical operators, we're going to evaluate them based on and or. Couple of examples here, 5 plus 3 times 2. First thing we're going to do is multiplication. So this is 6. 5 plus 6 equals 11. However, we can change this answer just by adding some parentheses. We evaluate what's inside the parentheses first. So that is 8 times 2 will give us 16. We then have our couple of code examples here. Let's walk through the evaluation of these. From left to right, let's do parentheses first. This is 15. Next, let's just evaluate this quick comparison here. Is 15 greater than 20? That is not, so let's say false. Now, what we could do here, since we see this is an AND operator, we already know this is false. We could evaluate this whole thing to false right now, but let's walk through and keep evaluating. 100 divided by 20, that is 5. Is 5 less than 10? That is true. However, since we have the AND operator here, this whole thing is going to be false. Our next example, 10 times 6, this is 60. 60 is greater than 50, this is true. Again, we could look at the OR operator here and say, oh, we already have a true. This whole thing is going to evaluate to true. But let's walk through again. 10 divided by 3 is going to be 3. 3 is not greater than 50. However, this is an OR statement, so this whole thing will evaluate to true. And then 10 modulus 3. 3 goes into 10 3 times, but then we have 1 left over. Is 1 less than or equal to 1? That is true. 20 times 3 is 60. Is 60 equal to 60? That is also true. And this is an AND statement. Both are true, so this whole thing evaluates to true. So we should have false, true, true as we evaluate this cell here. False, true, true. Perfect. Okay, we'll end this lesson real quick with a quick summary. We have our comparison operators. This is greater than, equal than, less than, all those that just compare numbers and values and everything. We have a few specific string operators, join, like, match, arithmetic operators, plus, minus, multiplication, division, modulus. This is performing calculations. Our logical operators, and, or, and not. Our different assignment operators, equals, plus equals, minus equals. A couple of different examples there. And then we talked about our operator precedence. With the operator precedence, when we're looking at if statements later, we will have statements like this. There won't be, math or anything like this, but you're checking those values. Is this equal to this? Is it not equal to this? Sometimes you can do those compound statements of using and or. That's where this is coming important, and just understanding how these operate and the order that they happen in as we go through and start introducing logic and evaluating decisions inside of our scripts. That finishes out lesson 3, and this is the last lesson inside of this module. Let's go ahead and close this out, and let's go into our challenges here and see what you can do to get started working with these different concepts we just learned about. The first challenge I have here is called a sentence analyzer. What you'll be doing is analyzing and modifying a sentence or a string using different string manipulation, comparison operators, and some of the methods we've learned about so far. Some of the things you'll need to know before you start this challenge. Again, we've talked about variables. They store and you can manipulate data inside them. For example, strings. String properties and methods can allow you to modify the text. We saw examples with toUpper to make it all uppercase, or replace parts of the string with other strings or characters. You can use comparison operators to help determine conditions. Example, greater than, to check to see if a sentence exceeds a certain length. And then you can create arrays by splitting strings into different words. First, let's take a look at the sentence I want you to evaluate. That sentence is right here. Farmer Jack realized that big yellow quilts, although very pretty, were expensive. Here are the things I want you to take with this string here and do with it. Just go ahead and print the original version out to the console. Then store the total number of characters into a variable and print that out to the console. Once you have the total number of characters, see if it is more than 50 characters and output if that is true or false. Next, convert that sentence into uppercase and store it into a new variable, then output that new sentence in all uppercase out to the console. Go through and remove any special characters such as dashes, parentheses, or periods, and store that cleaned sentence into a new variable. You can override an existing one if you want to, your decision there. You'll then print that modified clean version without any other punctuation out to the screen. Count the number of words in the sentence and output the result. I do give you a hint here, convert the string into an array using an operator or a method. And if you complete all these tasks, you should have output that is very similar to this. We have the original sentence, total number of characters. Is it more than 50? You should have true. This prints it out into all caps. This is without any parentheses, dashes, special characters, and then figuring out how many words are in the sentence. I do have a suggested solution here, but if you want to, you can use this interactive cell. I got it started for you here by creating the sentence variable with the sentence in it. If you want to go through and create a PS1 file and work with it through there, you totally can. If you're not familiar with creating script files or anything like that just yet, you can use this right in here and start writing your code and then execute it here and see the output, just like we've been doing through the other lessons. If you want, pause the video here, take this challenge, see if you can complete it, and then come back, unpause it, and we're going to go through my suggested solution. Your results may vary just a little bit, but as long as you get the same results, I think we'll be pretty good there. All right, let me go ahead and click on the suggested solution that I have here. First, we have the original sentence, and then we can just output it to the console. You can use write host if you want to. That just prints to the console. Doesn't do much for you later. We can talk about that, when working with pipeline objects. You can use write output, or you can just put the sentence on a line and it will output it to the screen. Next, let's determine the total number of characters. I did create a variable to store this in called character count. We have sentence.length, and then I wrote out, a string here. The total number of characters in the sentence is this. You could just output a character to the character count or your variable to the screen. Next, we need to do an evaluation. Is it more than 50 characters? I have my variable character count here, greater than 50. That is going to evaluate to true in this case. Because I already have this inside of a string here that I'm outputting, I do have to do my sub expression evaluation. So it is inside parentheses here, and then a $sign out in front. Again, what this is saying, inside the parentheses, evaluate this condition here, and then the $sign in front says now output the result of that condition or calculation. Let's convert it to uppercase, and in my case, I saved it to a new variable. Did sentence.toUpper, and then saved it to a variable called sentenceUpper and outputted it to the screen. Next, let's replace special characters. When looking at this sentence, we know it has parentheses and a period in it. We're going to take my original sentence here, .replace. Inside of single quotes here, I have my parentheses, and I'm replacing it with nothing. So this is two single quotes, but there's no space in between. When we're doing things like this and we want to keep the changes that we're making, this needs to be assigned to a variable. So I have new sentence. And then moving forward, I keep evaluating off new sentence. I don't go back and use my original sentence because new sentence now has the modifications I have. Again, we're going to replace this time the closing parentheses with nothing, and then the period with nothing, and then outputting new sentence to the screen. Next, let's count the number of words in the sentence and output that to the console. What we need to do first is take our new sentence that we were just working with. We're going to split it on each space. So this is single quotes here, but there is a space in between. This is going to turn our sentence or a string into an array of words. And then we can use .count on our array to figure out how many items are in it and store this into word count and then output that to the screen. We also could split this using a method. We could say new sentence dot split. In many cases within PowerShell, there are two different ways to do things like that. We could use a built-in method, or we could use an operator like this. Okay, that does it for the first challenge. In case you ran into any issues or have any questions, you can come back and look at the solution and go through and see how that compares to what you were doing. If you came up with something a little different or had something more interesting of how you completed it, leave a comment down below. It'd be really great, I think, for other people to see that. We'll go ahead and close this out, and let's go to our second challenge for this module. This one is to create a temperature converter. What you're going to do is take a temperature in Fahrenheit and convert it to Celsius. We're going to perform some calculations here. We will need to know first, again, you're using variables to store values. We can do different things, mathematical operations, addition, subtraction, multiplication, division. Don't forget your order of operations. And then the formula for converting Fahrenheit to Celsius, we have our degrees in Fahrenheit minus 32. Notice this is in parentheses. Or then multiply by 5 and then divide the whole thing by 9. What you'll need to do is create a variable that holds a temperature in Fahrenheit, apply the conversion formula to calculate Celsius, and store that into another variable, and then print both of them out in some type of user-friendly message. This is degrees Fahrenheit. This is what it would be in degrees Celsius. I do have a bonus challenge here. We talked about our different methods here, and you can find a static method in the math.net subclass to round the result to 1 decimal place. For example, this is what it would look like. 100 degrees Fahrenheit is equal to 37.7 repeating Celsius, or find a way to round that to 1 decimal place so you have a little bit better output there. Again, here's some example code to get you started, and you can work within this cell here. All right, so if you want, go ahead and pause the video, go give this challenge a try, and then come back and let's go through the suggested solution here. This is what I came up with. First, we have a variable here that is storing a value in Fahrenheit, so we have 100. And then you can apply your conversion formula. I did Fahrenheit minus 32 inside of parentheses, multiplied by 5, and then divided by 9. Our order of operations here is still going to evaluate this first part accurately. So this was the top of this was the numerator, and then divided by 9. If you wanted to break this down into easier steps, if you're worried about the order of operations and everything, that's totally fine. You could first say Fahrenheit minus 32 and store that into Celsius, and then say Celsius equals Celsius times 5, and then divide that by 9. If you want to break this down into multiple assignment operations and everything like that, totally fine. I did mine in a single line because the math wasn't super complicated, but if you have to break it down, do what you need to do. And then finally, we're going to display that in a friendly message here. So 100 degrees Fahrenheit is equal to this in Celsius. And then bonus, if you want to round to 1 decimal place, first we have the math class, 2 colons here, and we're going to use the round method. We'll pass in Celsius. This is the number we want to round, and then how many decimal places we want to round it to. And then again, using sub-expression expansion, this is inside our parentheses here. Actually, back up there, our yellow parentheses right there. And then a $sign out front, meaning we're going to evaluate this entire thing inside the parentheses and then display it out inside of our string. All right, that does it for this challenge here. That's my example solution. Again, your results may vary, but as long as you're getting the right result in the end, and then go back and maybe refine it, see what you can do better, maybe fewer assignment steps or anything like that, totally cool. All right, but that does it for this first module here. I'll include some other related videos that I think will help out in the playlist before we then get started with module 2, where we're going to talk about control flow. Thank you for watching. We'll see you in the next video.